You are listening to The Vocal Technologist. Spoken Tech for your ears.
Imagine trying to land a supersonic jet on a dirt road.
I mean, yeah, that is a disaster waiting to happen.
Right. Well, according to the stack of sources we are looking at today, that is effectively what 5 out of 6 companies are currently doing when they try to deploy AI.
It's wild.
Yeah, we are staring at this massive stack of data engineering and AI architecture news from early June 2026, specifically 2 huge drops from TLDR data. And the statistics are just staggering. Only 1 in 6 organizations actually has the underlying data foundation required for agentic AI.
It is a massive wake-up call for the industry, honestly. AI agents are, they're no longer just science experiments running in a sandbox on someone's laptop.
Right.
They are autonomous, they move at machine speed, and they're fundamentally breaking the data pipelines we've spent the last decade building. The tools we relied on for human speed analytics simply cannot handle the sheer volume and, frankly, the chaos of machine speed autonomy.
And that is exactly what we are unpacking with you today. Welcome to this deep dive into the sources. Our mission here is to sift through this mountain of architectural news and extract the underlying logic of what's happening.
Yeah, because to understand the current data landscape, we first have to look at the very things causing this massive paradigm shift, which is autonomous AI agents.
Which are basically chaos agents at this point.
Exactly. That is the root of the entire infrastructure rebuild.
Yeah.
And it explains why we are seeing massive industry consolidation, like the merger between Fivetran and DB Labs that was highlighted in our sources.
Right. They are joining forces specifically to build a trustworthy foundation for these agents. Because right now, the gap between what AI wants to do and what our databases can actually support is dangerously wide.
Yeah. And they didn't just announce a corporate merger either. They dropped some major open source innovations.
Oh, like dbt Core v2.0.
Yes. This new version uses a Rust-based engine called Fusion, which gives it incredible speed. But more importantly, they introduced something called the agent schema.
The agent schema.
Right. This is a standard designed specifically to give agents context about the data they are actually looking at.
Which addresses one of the most difficult engineering hurdles right now, right?
Yeah.
Persistent memory.
Yeah, exactly. Because how do you give an autonomous agent a state of mind? How does it remember a decision it made 5 seconds ago or 5 hours ago?
Historically, if you wanted an application to remember something, you just used heavy orchestration tools or a massive centralized cloud database.
But the developers building these AI agents are aggressively pivoting away from that. We are seeing a huge trend where they are ditching heavy shared infrastructure in favor of tiny local Scilite databases.
Heard with Leadstream, right?
Yeah, paired with Lightstream to create durable, backed-up workflows.
Okay, let's unpack this. Why in the world are we going backward to local Scilite for advanced cutting-edge AI?
I know, it sounds counterintuitive.
It does. Shouldn't these agents be hooked up to massive enterprise-grade Postgres clusters? I mean, managing these agents feels like letting a brilliant but chaotic intern loose in a filing room. My instinct is that you need a highly controlled, centralized environment to watch them, not an endless warehouse where they can just hide their messy notes in a corner.
Your intern analogy is actually spot on, but it leads to a totally different architectural conclusion.
Wait, really?
Yeah, think about it. If you give 100 chaotic interns access to one master filing cabinet, they're going to bump into each other, lock the drawers, and create a massive bottleneck.
Oh, I see.
Right. High availability and infinite scalability aren't always the most important things for an individual agent's memory. What you really need is cheap, highly inspectable state.
Inspectable meaning you can easily see what they're doing.
Precisely. If an agent fails or hallucinates or gets stuck in a loop, you want a simple, isolated file you can open up to see exactly what it was thinking at that exact millisecond.
Right. If you put all of that state into a shared massive Postgres cluster, you introduce complex network dependencies and just massive scaling costs.
Exactly. Squalite gives each agent its own durable little clipboard. And Lightstream just quietly streams the changes from that clipboard to cloud storage in the background, ensuring it's constantly backed up without slowing the agent down.
So you give them their own clipboard, not the master ledger. That tracks. But once they have their clipboard, how do we reliably tap them on the shoulder and tell them what to do? The sources mention a fierce debate right now over how to trigger these agents. Event-driven architecture versus polling.
Oh yeah, that's a big one.
My guess is that developers just want to use webhooks, meaning an event happens, a system fires a signal, and the agent wakes up and does the task.
That is the instinct, yes. Webhooks are event-driven and feel very modern. But here's the problem with that. Webhooks generally operate on an at least once delivery model,
Meaning they aren't guaranteed to just fire once.
right? They are unordered and they are essentially best effort. If the network blips, the system might resend the webhook.
Oh, wow.
Yeah, if your AI agent relies purely on that, it might execute a financial trade twice or fire off the same apology email to a customer 5 times because it received the trigger multiple times.
That would be a nightmare. But on the flip side, if you just rely on polling, where the agent constantly asks the server, do you have a job for me? Do you have a job for me? You will blow through your API rate limits in a matter of minutes.
Exactly.
So you can't rely on a push, and you can't spam the poll. How do you actually build a mature system then?
A mature system combines both, using something called structural idempotency.
Structural idempotency.
Yes. You use fast path events like a webhook for the immediate trigger so the agent reacts instantly. But you back it up with a slow, steady polling mechanism to catch any drop signals.
And to prevent doing the task twice. The agent uses an idempotency key. It's just a unique ID for that specific task. The agent checks its local Squalite clipboard, sees the ID, and says, oh, I already processed this event. I can ignore this duplicate.
That is how a long-running agent survives a messy, unpredictable network.
Exactly.
Building that sounds incredibly tedious, let alone testing it in a live environment where data is never clean. Which really puts into perspective what Hex is doing with Shoebox.
Oh, Shoebox is fascinating.
Yeah, according to the sources, Shoebox is an internal evaluation lab bench built just for testing these data agents. Teams can run an agent through a scenario, tweak its prompt or its memory, and compare the new run against a stable baseline to see if it actually improved.
Right.
But the detail I love most is that Hex had to create an entirely fake business called Shorelane Commerce just to test them.
They had to. I mean, if you test an AI on a clean academic database, it will look like a genius. But that doesn't reflect reality. Shorelane Commerce simulates the absolute mess of real-world data debt.
Right, ambiguous column names, deprecated tables, null values. Yeah, the exact kind of chaotic environment these agents will actually have to navigate when deployed at a real company.
And once you deploy them into that messy reality, a completely new problem emerges. Because these agents work at machine speed, they are constantly querying databases. They might fire off thousands of small, bursty questions a minute to figure out a problem.
And suddenly, the sheer volume and cost of those requests become unmanageable, which leads us to the massive rise of multi-query engines.
Because the economics of AI queries are fundamentally different.
Completely different. Traditionally, you might send a heavy, complex analytical query to a massive engine like Snowflake or BigQuery. But doing that for thousands of tiny AI checks is the equivalent of sending a massive freight train to deliver a single envelope.
It is ruinously expensive.
Yes, that is why the open source community is rallying around tools like QueryFlux.
QueryFlux is a Rust-based SQL routing proxy. It basically sits in front of your databases like a traffic cop.
Exactly. When an AI agent generates a query, QueryFlux catches it. It translates the SQL dialect on the fly, and then intelligently directs that query to the cheapest, most efficient engine available.
Whether that's Trino, Spark, or DuckDB.
Right, all of which are sharing the same underlying data tables.
It routes based on cost and efficiency. But wait, what if the agent is just totally hallucinating the SQL? We have all seen AI write a query that looks perfectly formatted but references a revenue column that hasn't existed since 2019.
Yeah, that's a huge issue. And that is where local context layers come in. The sources highlight a tool called DateTX.
ATX.
Yeah, instead of letting the agent invent SQL completely from scratch, KTX feeds the agent pre-approved company metrics and join logic. You're essentially putting heavy guardrails on the AI, forcing it to use crusted definitions before it ever sends a request to QueryFlux.
Okay, here's where it gets really interesting, because the AI shift goes way beyond just routing SQL queries. It is changing the core philosophy of how we retrieve information entirely. Let's look at Zepto's new cart contextual model.
This is such a cool use case.
Zepto has fundamentally changed how they look at a grocery shopping cart. They're using a transformer-based masked language model. That is the exact same underlying architecture as ChatGPT, but instead of reading paragraphs of text, it treats a shopping cart like a sentence.
If we connect this to the bigger picture, it is a brilliant application of the technology.
Yeah.
In a language model, the AI looks at a string of words and predicts the most logical next word based on context. Zepto is treating individual grocery items as the words.
Exactly. It looks at the items you've already added, factors in your geographical data and the time of day, and infers your intent in real time.
Right.
If you put tortillas, limes, and cilantro in your cart, it doesn't just run a dumb rule that says, suggest salsa. It inherently understands the sentence you are building and might suggest a specific cut of meat or a local brand of hot sauce. It is doing predictive text, but for groceries.
And they use a technique called inverse frequency masking.
What does that do?
It forces the model to understand the relationships between obscure long-tail products, rather than just constantly recommending the most popular items like bananas or milk.
Oh, that's smart.
Yeah. This shift away from rigid keyword matching toward true intent comprehension is happening everywhere. Meta is taking this exact philosophy to an absolute extreme with a system called Silvertorch.
Silvertorch blew my mind. The sources describe it as an index as model paradigm for their recommendation systems, like your social media feeds.
To understand why Silvertorch is revolutionary, you have to look at the old way. Traditionally, fetching recommendations is a multi-step, heavily engineered pipeline. You have a database index, you run an approximate nearest neighbor search to find similar items, you filter out things the user has already seen, and then you run a separate neural network to rank the final results.
A total Rube Goldberg machine.
Exactly. Silvertorch collapses that entire thing into a single, unified PyTorch model.
Meaning the index itself is the model.
Yes, it runs end-to-end on GPUs. They achieve this by using Bloom filters.
Those are the space-efficient data structures, right?
Right, they quickly tell you if an item is definitely not in a set. And they pair those with fused NT kernels, which are highly compressed computational pathways. By combining these, the model doesn't just search an index. The weights of the neural network contain the retrieval logic itself.
It's an incredible leap. But, this is a massive but, despite these flashy mind-bending AI advancements at Meta and Zepto, everyday data engineers still have to make these concepts work on standard earthly infrastructure.
Very true.
And they have to do it without bankrupting their companies. Because vector search, which is the math that makes this kind of AI retrieval possible, isn't just a magic wand you can wave over a legacy database.
Far from it. When you're dealing with millions of vectors, search quickly becomes a brutal exercise in memory management and index design. The Postgres Developer's Guide on our stack outlines these trade-offs beautifully.
Because at a fundamental level, vector math is incredibly heavy.
Exactly. You aren't just looking up a text string in alphabetical order. You are taking floating point numbers in hundreds of dimensions and calculating the physical distance between them to find similarity.
Wait, if everyone in the industry is hyping up vector databases as the future, why is Postgres warning us about massive trade-offs? I thought algorithms like HNSW solved everything. Isn't that the gold standard for speed?
Well, HNSW, which stands for Hierarchical Navigable Small World, is incredibly fast. You can think of it like a highway system for vectors, allowing the search to skip over vast distances quickly and zoom in on the right neighborhood.
Right.
But there's a massive catch. The physics of memory. To maintain that speed, HNSW requires the entire index to sit in your system's active RAM.
The entire index?
Yes. It is notoriously memory hungry. If your data set grows too large, your cloud computing costs will absolutely skyrocket because RAM is expensive.
Which means you have to start compromising.
Yeah. That is where you might pivot to an index like IVF flat or inverted file flat. This groups your vectors into distinct clusters, almost like grouping data by zip code.
Okay.
It uses significantly less RAM, but it requires constant finicky tuning to ensure your clusters don't get unbalanced. Or, if you're operating at massive scale, you use something called streaming DiskGAN.
Which streams data from solid-state drives so you can outgrow your RAM entirely.
Exactly. It's a sobering reminder that underneath all the AI magic, fundamental database physics still apply.
Manticore Search published a deep dive echoing that exact sentiment. They argue that vector search has to be tuned like heavy industrial machinery. You have to actively align your mathematical similarity metrics with your specific AI models and optimize how you chunk your data.
And this realization is driving a very pragmatic push across the industry. Companies are realizing they don't want to migrate petabytes of data into brand new vector databases just to do AI analytics. They want to make their legacy systems smarter.
Right, like Neo4j Virtual Graph. Graph databases are usually separate systems used to map complex relationships, like font rings. But Neo4j figured out a way to compile their specific query language, Cypher, directly into native SQL.
So you can run complex graph algorithms on your existing data warehouse without ever moving the data. It translates the logic on the fly.
It's about zero-copy architecture. Redis is doing something similar in their 8.8 release. They introduced a native array data type.
It sounds basic.
It sounds incredibly basic to anyone who has written a line of code, but in a distributed in-memory database like Redis, it fills a massive gap. It uses a hierarchical structure to allow constant time positional access. You can instantly jump to index number 1,000,005 without scanning the whole list using fixed memory.
And MongoDB is out here pulling off a magic trick of their own. They are running low-latency transactional logic without using stored procedures.
How?
By creatively combining bulk write operations with ACDRAN transactions, which guarantee that a complex series of database reads and writes either entirely succeeds or entirely fails, so you never get partial updates. They're using that to process complex payments at massive scale.
What you are seeing across the board is a strict focus on efficiency. Developers are exhausted by bloated architecture. And this is driving a parallel trend in the sources: the rise of hyper-pragmatic, incredibly cheap data tools. They want to do more with less.
Absolutely.
Which brings us to the absolute coolest hacker project in the stack: a blueprint for a live data app that costs literally $0 to run.
Oh, this is brilliant.
It uses public data, processes it using DuckDB, builds the interface with Astro and SVGs, and here's the best part. It uses GitHub Actions as a free, automated scheduling trigger to refresh the data on static hosting.
It is a phenomenal demonstration of utilizing free compute.
It's like building a sports car out of spare parts in your garage. You use the free gravity of GitHub Actions to turn the water wheel of DuckDB, which loads the data into memory, shapes it, and spits out a static image. It works perfectly and costs nothing, provided you don't need heavy corporate governance or shared business metrics.
Well, and pragmatism is fundamentally about matching the complexity of your tool to the actual business need. If you don't need heavy BI governance, why pay a massive vendor for it?
Right.
We see this same ethos with a tool called Ingester. It is a command line interface tool for ELT extract, load, transform. Instead of setting up a massive backend server to move data, you just run simple command flags. It extracts the raw data from a SaaS app, loads it directly into your warehouse, and lets the warehouse do the transformation. No custom code required.
And Pluto 1.0 just launched with a similar philosophy for data scientists. It provides a notebook environment for the Julia programming language, but it's fundamentally reactive.
Which solves a huge headache.
Yeah. In a traditional notebook, if you run code cells out of order, you can create hidden state bugs where a variable holds an old value and ruins your analysis. Pluto fixes that. If you change a variable in one cell, every dependent cell updates automatically, just like a spreadsheet. It is simple, effective, and eliminates hidden state entirely.
Even the massive cloud players are being forced to acknowledge this relentless focus on cost. ClickHouse just released CostBench.
Oh, right.
Yeah, it is an open source benchmark for cloud data warehouses, but it completely ignores raw speed as the primary metric. It ranks Snowflake, Databricks, BigQuery, Redshift, and ClickHouse strictly on price performance. It measures exactly how much analytical power you get per dollar spent. In this new era, cost is the new speed limit.
We saw this play out in an architectural showdown highlighted in the sources. A team ran 8 production use cases side by side to choose between 2 frameworks, Ray Data and Daft, for building a multimodal data lake. Daft has incredibly ergonomic code and great native primitives for handling different data types, but they ultimately chose Ray Data.
And their reasoning highlights the reality of scale. When you are doing complex asynchronous inference with large language models, individual compute nodes are going to crash. It is inevitable. Ray Data handles those node failures and redistributes the work seamlessly. The team prioritized pure distributed stability over elegant code, because when the messy reality of scale hits, you need a system that won't fall over.
But that pivot naturally forces us to look at the enterprise side of things. Your brilliant $0 DuckDB app is amazing for a side project, but when you do hit that massive scale, when you have thousands of AI agents creating petabytes of messy data, and you are subject to strict legal compliance, the architecture has to change again.
The sheer mess of data pipelines at that scale forces you into entirely different storage layouts. One of the biggest shifts we're seeing is the move to MOR, or merge on read.
Right. Historically, if you wanted to update a massive file in a data lake, you used copy on write. You had to synchronously rewrite the entire massive file every single time there was a tiny mutation.
Which is brutally slow.
Yeah. Merge on read changes that. It simply appends the small changes to a lightweight log file. It defers all the expensive, heavy merge work to a background process. You are effectively time-shifting the computational cost from the moment of the write to a controllable schedule. This is a game changer for high-frequency streaming updates.
And Databricks is pushing a similar evolution with liquid clustering. They released a breakdown debunking traditional Hive-style partitioning.
Oh, yeah.
In the olden days, you had to rigidly partition your data into folders based on specific columns, like date or region. But if query patterns changed, your partitions became useless. Liquid clustering dynamically organizes your data using keys that actually evolve over time as your data mutates.
So, what does this all mean for the database? It is essentially a massive library that magically rearranges its shelves overnight based on exactly which books people are actually reading, rather than forcing everyone to use a rigid Dewey Decimal System.
That is a perfect visualization. And the ecosystem around these massive tables is maturing quickly. Apache Iceberg 1.111.0 just dropped a crucial update called Register View. Previously, migrating views between systems was a nightmare.
Right.
This new feature allows you to seamlessly recreate existing Iceberg views directly from metadata files without having to reverse engineer the SQL. It closes a huge gap for disaster recovery.
But even with the best, most optimized storage layouts, the data flowing through them can still be garbage. How do you govern quality when AI is generating so much of the data?
You build systems that govern themselves. HaloDoc, for instance, had to build an Airflow-native data profiling framework. They were tired of data engineers running manual, ad hoc SQL checks across hundreds of tables to find errors.
So they automated it.
Yeah, they isolate each table's quality check in its own Kubernetes pod, running the compute on Redshift, which creates a fully self-serve, searchable dashboard of data health.
And DealHub just previewed their AI workbench, which takes this a step further. They are adding metadata-driven data quality decorators to their pipelines. These decorators inspect the data types flowing through. And they don't just throw an error and fail the pipeline if something is wrong.
Right, they actually auto-route their own remediation fixes and cast the data into the correct format dynamically.
The infrastructure is literally learning to heal itself. But there is one fundamental thing that AI cannot auto-route around, and that is the human element, the looming hand of regulation.
The legal pressure is intense.
It is. The sources paint a very clear picture of the legal pressure shaping this tech. The CPDP 2026 conference, which focuses on computers, privacy, and data protection, just wrapped up. Now, we're not taking any stance here, just reporting what they covered, but the panels impartially mapped out massive regulatory concerns. Things like strict biometric age gating requirements, the digital rights of children interacting with AI, and the massive privacy implications of chatbots. To put the scale of the privacy issue in perspective, the conference noted there are 230 million health-related queries happening on ChatGPT every single week.
And the engineering world is scrambling to build a compliance architecture to protect that data. Google just introduced a zero-trust private analytics system utilizing trusted execution environments, or TEEs.
A T is essentially a hardware-level black box on a server chip, right?
Exactly. Data goes into the black box encrypted, it is decrypted and processed completely in isolation, and then the raw data is destroyed. Even the owner of the server cannot see the individual data points inside. It ensures that only anonymized population-level insights are ever visible to the analytics team.
We are also seeing companies like Cerbos laying out the groundwork for authorization patterns ahead of the EU AI Act deadlines. They are decoupling security policy from the application code itself, detailing the specific identity and audit patterns that engineering teams must build to enforce rules on these AI agents.
And OpenTelemetry just launched their Blueprints initiative to standardize how we monitor and observe these complex distributed systems.
All of this compliance technology points back to the core disruption we started with.
Yeah, this raises an important question. How do you practically enforce least privilege access? Meaning, a user only has access to exactly what they need when the user executing the query is not a human employee, but an autonomous agent operating at machine speed, navigating multiple databases simultaneously.
It is a completely different ballgame. The permissions, the routing, the storage logic, the memory constraints, every single piece of the stack is changing. So to bring this all together for you listening, if you had to distill everything we've unpacked today across this massive stack of sources, what is the core takeaway?
The takeaway is that the entire data ecosystem is undergoing a fundamental retrofit, from how we structure our storage logs, to how we route queries intelligently, to how we design our vector indexes around the physics of RAM. It is being rebuilt from the ground up to survive the speed, the sheer volume, and most importantly, the autonomy of AI agents. The infrastructure that worked comfortably for human analysts is officially being retired.
And that leaves us with a pretty profound final thought to mull over. As these autonomous AI agents begin to generate more data, write more code, and execute more complex queries than human beings ever possibly could, are we even building databases for ourselves anymore? Or have we already crossed the threshold and started designing digital habitats exclusively for our AI counterparts? It feels like we are just the landlords now, building the filing room for that brilliant, chaotic intern and simply hoping the walls are sturdy enough to hold them. Thank you so much for joining us on this deep dive into the sources.
Spoken Tech, for your ears.